Hi, I have your question from the homework here. And the first thing I did was I found the formula for partial sums for geometric series. And that's the one we need to use to solve this problem because they tell us it's geometric and we know it's a partial sum, which means we're adding up a certain number of terms. We just don't know what that number is yet. So I substituted in the total sum, 23.25, that was given in the problem, the first term, 12, and then the common ratio, which is 0.5. And that's all we know. It's the n value that we're looking for. So now I'm just going to simplify anything I can. And the first thing I'm seeing is the 1 minus 0.5. That's the easiest thing to simplify. So I'm just going to copy everything else down. 1 minus 0.05 to the n power. I'm not changing anything, and I'm just simplifying this denominator to 0.5. Okay, so now I see it's 12 times everything in parentheses, so I'm going to get rid of 12 first. Opposite of multiplication is division. We can divide each side by 12, and the 12s will cancel out. So now we have 23.25 divided by 12. I have my calculator here. 0.25 divided by 12. And that is 1.9375. And that's going to equal 1 minus 0.5 to the n power over 0.5. Okay, now we're going to multiply each side by 0.5. I'm just multiplying. And we end up with 0.96875 equaling 1 minus 0.05 to the n power. Subtracting by 1, because I'm just subtracting 1 to each side. So the 1's cancel out. And now I'm left with negative 0.03125. We have a lot of decimals here, equaling negative 0.5 to the n power. Okay, so then the last thing I can do right now is if I wanted to make it all positive, I could multiply or divide everything by -1 to have 0.03125 equaling 0.5 n. Okay, so now we're kind of stuck. And we're thinking back to those equations with exponents. When we get stuck, what can we do? And if we have a variable in the exponent, we can change the form to a logarithm because I don't see any easy way I can make these the same base with converting them. That's really messy with the decimals. So I'm going to change it to a logarithm with a base of 0.5 and then 0.03125, and that's going to equal n. So we're close, but we still need to figure out what this means. And now at this point, it depends what type of calculator you have. Some calculators, it will allow you to enter a different base, and others won't. It just depends what model. So you can test it out, press the math button, and scroll all the way down until on mine it says A. It's under 0, so you just have to keep going down, and it says it looks like this. It says A, then there's an arrow, and it says log, and then base. And again, I just press the math button. And if you have that, you can enter this in exactly as it looks because it shows up as log, and then there's like a little blinking square and then another one. And you can enter these numbers in exactly as they are, and it will show up to be 5. So then we see that n equals 5, and we know we have to add up the first 5 terms in order to get the given sum. If your calculator does not have that option, it's not a problem at all. because we can use the change your base property. And what that means is, I'm going to just copy this down again here. If we want to evaluate, we have a base of 0.5 and then we have 0.03125. What we can do is break this up, and then we can write it as a common logarithm or a natural logarithm, either one. And we can say the log of 0.03125. You can, because all calculators have the common logarithm button. And we can divide that by the common log here, 0.05, because we're changing the base and writing it with division, and this will also equal 5. So if you can't enter with the different bases, you can use this property and we will also end up with 5. Either way will work.